Look at writing and solving equations from word problems, and we're also going to solve by graphing. So number one, Rayshawn and Erica both plan to run for a spot on the school board in their city. They must each collect a certain number of signatures to get their name on the ballot. So far, Rayshawn has 15 signatures, but Erica just started and doesn't have any yet. Rayshawn is collecting signatures at an average rate of 5 per hour, while Erica can get 10 signatures every hour. So first up, write a system of equations. A system are two or more equations. So we're going to write two equations. That'll be our system. Let's go back and underline the important information. So Rayshawn has 15 signatures, and he can collect them at 5 per hour, while Erica can get 10 signatures every hour. All right, so here's Rayshawn's equation. He starts with 15, and he can get 5 every hour. And then for Erica, she can get 10 every hour. So we're going to graph these on the same coordinate grid right here. I'm going to rewrite their equation. So again, Erica was y equals 10x. And Rayshawn's was, he started with 15, and he collected 5 every hour. All right, so let's start with Rayshawn. 15 is his y-intercept. He's collecting 5 every hour. So 1 hour, another 5, 1 hour, another 5. And I'm going to connect those with the line. Okay, so here's what Rayshawn's line looks like. Let's look at Erica's. She starts at 0, but she collects 10 every hour. And if we connect her line, it looks like this. Oops, not like that. Okay, so the question is, write a system of equations for Rayshawn and Erica. We did that. We graphed it. And then I think it asks, assuming that the rate of collection stays the same, eventually the two will have collected the same number of signatures. How many signatures will they both have? Okay, so how many? So here's signatures. They have 30 signatures. And how long did that take? Well, that's hours. So if we go down, so here's the number of signatures. How long did that take? It took them 3 hours to gather the same amount of signatures. All right, let's try another one. A video rental company offers a plan that includes a membership fee of $10 and charges $1 for every DVD borrowed. The second plan costs $40 for unlimited DVD rentals. Write a system of equations that represents this. All right, so the first one is $10 every month plus $1 for every DVD rented. So there's one way to write this equation. We could also write 10 plus x or x plus 10. The other plan is $40 per month for unlimited. Oh, so I should change this because we want x to be the number of months. So it's $10 for every month. Well, let's see what they want for our variables here. So this is cost, DVDs. Okay, so DVDs is the x value, and this is the y value. So let's go back then. Okay, so the first one was correct, 10 plus 1x, and the other one's just $40 no matter what. Okay, so let's graph these two and see where they intersect. So the first one starts at $10. I'm going to need more room here. Okay, so DVDs is on the bottom, so remember that. Oh, I want to make it so I can see it a little bit better. Okay, here we go. So the first one, again, is starting at 10. It goes up 1 for every month. So start at 10. And for 5 DVDs, it goes up $5. For another 5, it goes up another 5, and so on. So here is my line here. So for every 5 that you rent, it costs $5 extra, or for every 1, it costs $1. The other one is y equals 40. Okay, so the y-intercept's 40, but the slope is 0, so here's what it looks like. Okay, and I should have drawn my other line better, so let's try the other one better. Okay, so here's what it looks like. I'm going to keep drawing my dots up. Okay, so that'll give me a better line right here. and the other line was starting at 40, no, slope. And we're going to look for the point of intersection. So our point of intersection of our system of equations is right here. And I think it will ask us if a customer borrows enough DVDs in a month, the two plans cost the same. How many DVDs is that, and what is the cost? Okay, so here's the cost. It's going to be $40, and that is if they rent 30 a month. So let's write that down. So they cost the same at $40 if 30 DVDs are rented. And so using the graph, if you rent any more than that, you would probably want this $40 a month. Otherwise, it's cheaper to have that first plan if you rent less than $30 or 30 DVDs a month. The pink is cheaper. If you rent more than 40 DVDs a month, then the black one is cheaper. Okay, let's do a few more, and the rest will be your assignment. Okay, so the next one, Mohammed, an office manager, needs to find a courier to deliver a package. The first courier is considering charges a fee of $20 plus $3 per pound. The second charges $10 plus $4 per pound. Write the system. All right, so the first guy is $20 plus $3 per pound, and the second one is $10 plus $4 per pound. Let's graph this. All right, here. And again, I'm going to rewrite our equations. So 20 plus 3x. And the other guy is 10 plus 4x. All right, so the first one starts at $20. And for every, this is going up by 5 pounds. I'm going to go up by every 10 pounds. That'll be easier. So let's say that it's 10 pounds. I'm going to plug in 3 times 10 is 30. 30 plus 20 is 50. So the next one would be, if we go over 10, we're going to go up to 50. So it looks like when I'm doing this, my rise is 1, 2, 3 over 2. 1, 2, 3 over 2. So here's the next one. And again, all I did is plug in $10 to figure out what my next point would be. So here is my graph. Okay, then the other one starts at $10 a month. And again, let's go up by every 10. So I'm going to plug in at 10 right here. 4 times 10 is 40. 40 plus 10 is 50. So this one, it would be the same at 50. So this goes up 1, 2, 3, 4 over 2. 1, 2, 3, 4 over 2. So here's the other dot. Okay, so we can see where they cross here. They cross, they both cost $50 when they weigh 10 pounds. So let's write that down. Mohammed determines that given his package weight, the two are equivalent. And how much will it cost when they're equivalent? Well, $50 at 10 pounds. We could also write that as a coordinate 10, 50, keeping in mind that x is weight and y is money. Okay, let's do one more. 2 workers in a holiday boutique are filling stockings with gifts and candy, small gifts and candy. Thea has already filled 5 stockings and will continue to fill them at a rate of 3 stockings per hour. And Anidra, who just arrived to help, can fill 4 stockings per hour. Rate your system. Okay, so here's Thea. So 5 stockings plus 3 per hour. And Anidra can do stockings at 4 per hour. So let's write those equations down again and graph them. Okay, so again, Thea was y equals 5 plus 3x. And Anidra was 4x. And again, hours is on the bottom here, so I shouldn't have cut that off, but I did. Okay, that's better. So we had y equals 4x. Thea was y equals 5 plus 3x. All right, so here's Thea. We're starting at 5. We're going up every 3 every hour, or let's plug in for 2 hours. 3 times 2 is 6. 6 plus 5 is 11. So after 2 hours, she's up to 11, and here's 15, so I'm going to kind of estimate. Let's go another 2 hours. So when we're at 4 here, 3 times 4 is 12. 12 plus 5 is 17. So that's about right here. And then the second one, Nidra, she starts at 0, but she goes up 4 every hour. So after 2 hours, she's gone up to 8. After 4 hours, she's gone up to 4 times 4 is 16. After 5 hours, she's gone up to 20. Okay. And let's do 5 hours for this, for Athea. 3 times 5 is 15. 15 plus 5 is 20. Okay, so this is when they're the same. So again, here's 1. And you can see where they cross. They cross at 20, at 5 hours. They cross at 5 hours. Okay, so at 5 hours, each of them has filled 20 stockings. So 5 hours, 20 stockings. All right, we'll do one more, and then the rest, I think there's, how many total? 10 total, so it'll be 5 for you to do on your own. Okay. Yesterday, 2 friends went into a bank to open a savings. Maddie started by putting $200 into her account, so let's put that here. And she will deposit 16 each week. All right, so that was Maddie. Lily made no initial deposit, but she will add 20 a week, so let's put Lily down here. Okay, let's graph our 2 equations. Okay, so again, Maddie was 200 plus 16x, and Lily was 20x. Okay, so let's graph Maddie's first. She starts at 200. She goes up about 16. Here's 100. Let's just put in a 20 and see what happens if I type in a 20 here. So let's do my scratch pad. 200 plus 20 times 16. Was it $20? No, 16. Oh, 16 times 20, so that's fine. Okay, so she's at 520 this week. So here's 500. Here's about 520. Let's do another week. So for 40, I'm going to plug in 200 plus 16 times 40. 840. Okay, so here's 8. So 40. Did I type that in right? 200 plus 16 times 40. 840. Seems to jump too much here. Let's double check. Okay, 16 times 40. Plus 200. Okay, so that's 840. Did I do the other one right? 16 times 20. Plus 200. Oh yeah, 520. Did I graph? No, I didn't. That's why I didn't graph it right. 520 is not right there. All right, so here's 500. Here's 520, about right here. And the other one's 840, so 840 is about right here. Okay. So there's Maddie. Lily starts at 0, but she goes up $20 every week. So let's do 20 times 20 for 20 weeks. Calculator here. So 20 times 20 is 400. Okay, so she's 400 here. Let's do 20 times 40. Okay, so that'll be 800. So here she's at 800. And let's do 20 times 60. It's 1200. Okay, so that's going to be like way up here. Okay. So mine will not be exact. We can get close. Okay, so where they cross, and I should have cut off my graph. Oops. Okay, so it's going to be about here where they cross. Looks like it's about here. And so this is 800, 900, I'm going to estimate. So I'm going to estimate about 1,000 We can check our answers too. And it's going to take them about 50 weeks for them to get $1,000. Then it looks like it's about the same. Let's try it. See how close I got. 16 times 50. Plus 200. Yeah, it looks like. Yep, that's right. So we get 1,000. Yep, so this one is at 50 weeks. They have $1,000. Okay, so in class there's 5 more for you to write the equation and graph them. Remember, you can plug in values to make your table, so we'll practice that more in class. And then we'll go over any questions tomorrow.